For centuries, we looked up at the night sky and wondered, what's out there? The moon was our first step, Mars is our next. But what about Mercury, the mysterious world closest to the sun? Can humans even survive this journey? Today we will explore two of humanity's most daring frontiers, how we will reach Mars and whether it's even possible to reach Mercury safely. It isn't science fiction anymore. This is the story of the greatest adventure humanity has ever planned. The dream of Mars. Mars has always been our cosmic mirror, similar yet so alien. Cold, dusty, and red is the planet that no one once had rivers, lakes, or maybe even life. It's close enough to reach, but far enough to challenge everything we know. Elon Musk says we could have a self-sustaining colony there within decades. NASA's Artemis project aims to build the foundation of the moon first, a launch pad to Mars. But before we dream of Martian sunsets, we have to solve the impossible, the journey itself. Mars is about 55 million kilometers away at its closest approach. Even at top speed, it takes 6 to 9 months just to get there. That means a crew will live inside a metal capsule, isolated, confined, and exposed for nearly a year before even landing. The road to Mars. How do we make that happen? Step 1 is propulsion. Right now, rockets like SpaceX Starship or NASA's SLS can reach orbit and beyond. But chemical rockets are slow. The future lies in nuclear and ion propulsion, engines that use less fuel, go farther, and stay in space longer. Step 2. Life support. Astronauts will need oxygen, water, and food for a 2-year round trip. Carrying everything isn't practical, so we will recycle, turning carbon dioxide into oxygen, urine into water, and waste into fertilizer. Step 3. Radiation protection. Between Earth and Mars, there's no magnetic field, no thick atmosphere, just deep space radiation. One major solar flare could end the mission instantly. So, engineers are developing shielded habitats, using water tanks or even Mars' own soil to absorb radiation. When they land, astronauts might live underwater and underground, or inside 3D printed domes built from local regolith. The hardest part isn't the technology, it's the people. Imagine living months away from Earth, seeing no blue sky, no ocean, no family, just the endless void. The psychological stress will be immense. NASA studies that constantly, stimulating missions in isolated chambers in Hawaii or Antarctica. They found the team's mental strength and emotional stability matter as much as physical health. A Mars mission will demand not just astronauts but philosophers, engineers, and psychologists in one. Arriving on Mars. Landing on Mars is like threading a needle in a hurricane. The atmosphere is too thin to slow you down, but too thick to ignore. NASA's 7 minutes of terror describes what happens as the spacecraft enters Mars atmosphere, slowing from 20,000 km per hour to the safe landing in just minutes with no control delay. Future landers will need supersonic retro propulsion and autonomous guidance, and once we are there, solar power and nuclear generators will sustain life. The first humans on Mars will be pioneers, not tourists. They will build, test, and prepare for those who follow. And then Mercury. What about Mercury? It's smaller than Mars, closer than Venus, but it's a completely different kind of challenge. Mercury sits just 58 million kilometers from the Sun, bathed in solar radiation hundreds of times stronger than on Earth. Daytime temperatures over 430 degrees Celsius, hot enough to melt lead, while night drops to minus 180 degrees. So is it even possible to reach it safely? Technically, yes. It's far harder than reaching Mars. You might think Mercury is closer, so the trip is shorter. But in orbital mechanics, closer to the Sun means falling faster towards its gravity. To reach Mercury, a spacecraft must slow down dramatically, fighting the Sun's pull every step of the way. That's why reaching Mercury takes more fuel than reaching Pluto. However, we've already done it. So far, only 2 missions have orbited Mercury: NASA's Messenger and European-Japanese Baby Colombo, which is still on its way. They use gravity assistance, slingshotting around Earth and Venus multiple times to shed speed between gently dropping into Mercury's orbit. That's the trick. Mercury demands patience. You don't race towards it, you dance your way in, one orbit at a time. Could humans ever go there? In theory, maybe centuries from now, we'll need advanced materials that can reflect heat, radiation-proof habitats, and spacecraft powered by high-efficiency propulsions. It's not impossible, just extreme. So why push this farther? Why it matters? Why risk everything to reach Mars even dream of Mercury? Because exploration is in our DNA. Because every new frontier reshapes how we see ourselves. Because when humanity looks outward, we evolve inward. The technology we invent to survive Mars, energy systems, recycling tech, AI-driven mechanical tools will transform life back to on Earth. The data from Mercury teaches us how planets form, how solar systems evolve, and maybe how life begins. Every mission isn't just about space, it's about understanding us. So yes, can we reach Mars? We're building the rockets, habitats, and the courage to do it. And Mercury? One day, maybe, not soon, but someday. Because history shows us this truth. Every impossible journey begins with a question. We once asked, can we fly? Then can we leave Earth? Now we ask, can we live on other worlds? And if humanity keeps dreaming, the answer will always be yes. Thank you for watching, everyone, and remember, the distance between impossible and possible is measured in human imagination. If you like this video, like, share and subscribe. Goodbye.